Hello, good morning and welcome to this webinar in our series of Beyond Modelling webinars. My name's Stephen Jones and today I'll be talking about Agile development for simulation modelling. Just a point to note, we'll be taking questions through the session on the WebEx. But we will try and answer some of those questions at the end of the session, and if we don't get around to answering those, we can answer some of those offline as well. Okay, just a bit about what we're going to cover. I'm going to be talking today about a methodology for structuring your simulation model project. That method is called Agile. It also goes by the name of Scrum or Extreme Programming. We'll cover some of these terminology points through the presentation. We'll also be covering a bit about requirements capture and design process for simulation models, and also a bit about verification and validation in specifically relating to Agile model development. This webinar is aimed at a whole range of different people, including sponsors of simulation projects. So this is people who might know that they require a simulation modelling project doing for them, and might be getting external people to carry out that project for them, or maybe internal consultants, or maybe analysts that work for them. It's also applicable to simulation modelers, people who build models day to day. Agile is also applicable to anybody doing any sort of end-user development, so developing a tool for use by other users or by themselves, such as a simulation model, but also things like spreadsheets that have got an ongoing use, web development, wiki development, databases, or even a CAD layout. Projects of these sorts of natures could benefit from an Agile methodology. I should point out that my background is in simulation modelling. I've been doing modelling for a little over 10 years. I've been with Lanner for about 3 years. I'm by no means an expert in Agile, but I've used it recently, and I've learnt quite a bit from our software developers, and I think it's a useful topic for simulation modelers and for people involved in simulation generally. So onto the steps of development of a simulation model. An important thing to start with is to understand what's required, what business questions you might want to answer, what decision you're improving by doing your project. The next step obviously is to decide what to do about that requirement, to design a solution, to specify what that solution will be, and then go ahead and develop it. And then the next steps are obviously to check that it does what it should do, and that involves checking against the design. Does it do what we planned it to do, and does the solution meet the requirement, which is the important part of developing a model or a piece of software. Does it do what we want it to do? And then obviously there's a final step as well there, which we'll be coming back to, which is you still need to use that solution to drive the value in your business, to answer the business questions, or to do whatever it was designed to do. During all of those steps of a project, we want to keep in mind at all times who are the users going to be. If you're developing a solution for yourself, that's fairly easy to understand the user's point of view. But if you're not the person who's going to be using the tool that's being developed, then it's always important to keep in mind their viewpoint. Also important to consider how the users will interact with the solution. Not just what will it do, but how will people get it to do that. What are the decisions it will support, and what sort of cycles do those decisions sit in? Is that a one-off decision, or is that a cycle of decisions taken every week, every month, every quarter? Also, what are the full range of questions people want to ask of the solution? There might be a few key ones, but it's important to think of all the other things that the tool might be able to give you if it were designed in the right way. So a traditional approach to those steps of the development life cycle are to capture the requirement, design a solution, implement that solution, and to verify and validate. And this is often called the waterfall model, due to that diagram there. It's also called the V model when we flip the verify and validate sections up on end to show that the verification is done against the design specification and the validation is done against the requirements of the solution. This is the traditional approach, is to specify all the requirements of the tool, go ahead and design a full solution to it, to implement that, and then to go ahead and verify and validate it, and hopefully just go through that loop once. That traditional approach has many uses, has been used for a long time, and is still appropriate in a number of circumstances. But what I'd like to go through today is another approach, which is Agile. So, Agile development methodology, where does that come from? It comes from the software development community who have developed it, and a number of different flavours of Agile processes. Why is it called Agile? It's called Agile because it uses an iterative process which keeps responding to changing requirements and a changing understanding of which design would best meet those requirements. And it exists because requirements do change, because design processes change, and software development projects were often ending up expensive, unwanted and unreliable after this one-hit development stage. And there was no then recourse to change the path of that development as it was going along, or to go back and change that development after it finished was another expensive process. Why are we applying it to simulation projects? Well, I think software development and simulation model development have a lot in common. They both involve coding something in an abstract way, with links to the real world, and often they're very complex projects. There are many more similarities between simulation model development and software development, which we'll probably see through the following slides. So, the Agile development methodology assumes you've captured your requirement, and if we think of our requirement as that little blue blob there, we'll go into a bit more detail about how we specify what that blue blob means, but for now let's just think of it like that. All of our requirements then add up to a product backlog, which is a bit of terminology in Agile to describe all the requirements that have been captured. That product backlog should be as complete as possible, but you can always add to that, and you can always prioritise which items are more important to you. The next step in the Agile development methodology is to identify a subset of those requirements which are the highest priority to you to complete first, and to do what is called a sprint, and they become the sprint backlog. The sprint backlog, it's normally an aim to get that sprint backlog to get to a point where the model is usable and is complete in many ways, but can be added to by further sprints, which might add further items off the backlog. Often as well, the sprint is identified as a period of time rather than a number of backlog items which you wish to complete. We time bound it, so for example we might think, how many of these requirements can we get within a 2-week period, and identify the sprint via how much we can fit into that 2-week period, rather than say we want to complete these requirements, therefore how long will our sprint be. Okay, so once we've got our backlog and we've got a sprint lined up, we can go ahead and do that. And we get to the end of that sprint, and we might do a review of what was completed and what wasn't, and a delivery of that simulation model to whoever is due to use it, and do some user acceptance testing where they test that everything is as they would expect it and meets the requirement set out in the sprint backlog. So then we can release the model, and we can go back around this iterative loop, iterative cycle, as many times as we wish. Obviously, what I'm describing there is just the development of a simulation model, and that's not the whole story. As that handover goes on, then there is a model with the user which might be being used for experimentation. So at that point, the user of the tool can go ahead and use it. This happens with software. You probably find your browser or other software is being updated continually these days, and you're using the latest version, and then at some point a new version comes into use. Now that cycle on the right hand side of experimentation with a simulation model can generate further understanding of what's required, and that feeds in again to the product backlog and to the prioritization of what's in the following sprints. So some more terminology around Agile. It's come out of the software development community, and there's a lot of sort of different terminology which might not be understandable to the new user of this method. So a Scrum is a session where the team involved in the development of the solution get together to decide what the sprint should contain, and the Scrum Master is the person who's responsible for controlling that process and making sure that the scrums are organised and documented and happen at the regular intervals that they should happen at. Another important Agile bit of terminology is that there is always a customer or a product owner, somebody who owns the requirement and who normally is the person who would use the tool under construction, and they would be responsible for making sure that requirements are being met and updating the backlog through the Scrum Master. So user stories are a description of each requirement about how the user might go ahead and use the tool in question. And normally the requirements in Agile development are tried to be constructed in such a way in which they're a sort of equal size of workload for each requirement. So each user story should be about the same size. If we get a story which is particularly big, in fact could be broken down into a number of user stories, we call that an epic, in the same way as in literature an epic is a construction of many other stories. Another bit of terminology, project velocity refers to the number of backlog items which are being completed, so the rate at which sprints are getting through the backlog. It's an important concept just to understand whether those stories are of equal size and whether any problems, technical or otherwise, are being encountered along each sprint. So project velocity is a tool to measure the progress of your project. Refactoring is in some ways descriptive of what it does, but it's a process by which we revisit the assumptions which we've built into our simulation model, or even just revisit the way that the simulation model has been constructed, and consider whether that could have been done in a better way, knowing what we now know. And refactoring is a process of going back and cleaning up and otherwise fixing things that we think could be done better, whether that involves changing the model behaviour or whether that just involves keeping the model behaviour the same but changing the model to do that in a more efficient way. That's what refactoring is all about. A stand-up meeting is, again, as it describes, a meeting which is typically done daily, where everyone stands up to keep the meeting short and discusses progress that's been made, any problems that have been encountered. The stand-up meeting is typically done between the customer, the Scrum Master, and the people involved in development. That might only be 2 or 3 people in a simulation model, but it generally involves people involved in the project getting together on a regular basis for a short amount of time to discuss where they're up to. Okay, a spike is a similar concept to a sprint, so it's a period of work in which we carry out changes to the development of the solution. I've got a slide here to describe a bit more about what a spike is. Now, if we don't understand very clearly the requirement, and we can't articulate that requirement very clearly, or we know what the requirement is, but we don't know the best way to go about designing the solution to that requirement, then we have a bit of a black hole in our requirements or our design. And a spike is a period of time in which we do some exploratory work, normally looking at a few different options of ways to articulate the requirement or ways to develop a solution to a requirement which is maybe slightly more unknown than the rest of the backlog. Okay, so Agile is a process, as I've described there, and a series of ways of thinking about that process. It's not an easy way out. It's not a way of doing things where things are ad hoc or out of control. It's a way of controlling a simulation project or a software development which is controlled, where requirements are understood and design specified, but in iterative cycles, so that more can be learnt about the solution as time progresses and as new versions of a model or a piece of software become available. That iterative method has been proven to work very well for software and very well for simulation models as well. Most people who've developed a simulation model which has ongoing use will know that new requirements crop up all the time, and the trick is to manage those well and to document everything in that process to go on carrying on developing it. So to think about requirements, I thought it was this is possibly basic for some of you, it's possibly informative for other people. I just wanted to say a bit more about requirements capture. So I've got an example model here that I want to build, where I want to model the ATM queue and the bank queue of people waiting for banking transactions. And I want to do that so that I can decide how many ATMs are required at each location. So this is a requirement of a banking organisation maybe, and they know that requirement would be satisfied when they know the distribution of likely waiting times for customers for those banking transactions. This at the moment is a fairly good requirement, but it could be made better, and I've got a few ideas for characteristics of a good requirement. For one, they should be atomic. They should address just one thing, and at the moment we haven't got that, so we could improve slightly. So here I've split the requirement into two, and I'm also a bit more specific about the type of ATM I'm interested in, because that might affect the waiting times for the customers. But we can continue to improve this backlog. We should make sure that our backlog is complete. There's nothing implicit or missing from our requirement that we are assuming should be done, but we haven't articulated. We should also try and be consistent and unambiguous about our requirement. So one of the backlog items shouldn't contradict another and shouldn't need any further information to understand. So we might need a bit more description on our three text boxes there. I also want the requirements to be traceable and current, so I want them to I've added a requirements number so we can refer to them just by the number there. A sponsor so we can trace them back to the person who wanted to add that to the backlog, and a date of when that happened. And we've also started to prioritise who considers what to be high priority or low priority, and that's a good way to make them traceable and understand what's most important. We also, it's very important to have that condition of satisfaction. When will I know that the requirement has been fulfilled? That's what I'll need for my validation. How do we know that that's been done? We know because we've specified what the condition of satisfaction will be. Design in a similar way is normally we attempt to make that as atomic as possible. So we make a specification for just one thing. Most of my examples here are witness based, so they are modelling specifications, but it's very important here to capture not just the modelling specifications but all of the user interface specifications, all the output and results that are required. So everything to do with the solution should form part of the model design document. As with the traditional approach, the V model or the Waterfall, we test in Agile against the design specifications and requirements in each sprint. There's really no shortcut to that process. But there's a few ideas here from software development communities of different ways to think about verification and validation. In addition to thinking about have we met the design specifications or have we met the requirements in the backlog, we could also think about have we covered all of the code or the decision branches that would go on within a simulation model. So this might be tracing a part through every particular branch that might be possible within your simulation model, or making sure that every bit of code is covered, so every possible eventuality has been tried at least once, or for example trying a decision table where we try lots of combinations of input parameters to make sure that as many different aspects of the model have been tested. Software developers often have automatic tools for testing as well, so this is something you might wish to consider with your simulation model. Could you save the tests from one sprint to the next and repeat those tests after the next sprint if they're appropriate, and therefore form a testing profile where you reuse the tests that are available to you. There are also automatic tools available for documentation, for example Witness Documenter. That is a tool which will allow you to very quickly document your model and to use that for validation purposes, including through a code review where somebody steps through line by line against each of your bits of code. Also important to remember is use the innate visual nature of simulation. If you've got diagrams or a display or charts in your model, use those to verify and validate your model. They're very important. They can show very quickly what's going on within your model, and if anything shows up as not particularly valid, then it's often very easy to see through the visualization as opposed to looking at rows of outputs of numbers, for example. Okay, so what I've been talking about today is a methodology for your simulation project. It's not a shortcut. It is an iterative process designed to help you develop a requirement and develop a simulation model which is going to be relevant to whoever needs to use it and whoever needs the results of the decisions that are being analysed. But those simulation projects can still be supported by all the other disciplines around that. So we've talked a bit about managing each sprint. Project management still needs to be in place for each of those sprints. That's another discipline which people involved in simulation projects need to have that skill. Another good skill to have is configuration management, and there are some tools out there to help with this. I've personally used Visual SourceSafe as a configuration tool for files, but also Microsoft SharePoint, and another one out there from the software development community is Git or GitHub. These tools are there to enable you to manage the different branches and different master files that are part of your project. Another skill you need as a simulation modeler is good user interface design. So that needs to be considered at all the stages of your different sprints. And again, there are lots of good books out there on user interface design. It's worth keeping up all of these skills as part of your methodology for your simulation projects. Okay, so that's about me complete for today. If you need any more help, feel free to pose questions to us, or if you have any further questions, don't forget to check the Lanner support portal or ask your Lanner consultants if you know any. If you don't know any, feel free to get in touch via the help desk, and you'll get in contact with a Lanner consultant pretty quickly. And there's some links there to some useful websites for thinking about Agile. If you're thinking about implementing that on one of your projects, there's some more information there for you. Thank you all for joining me today. Goodbye.